We are coming to discuss reverse bearing or backward bearing. But before then, I would like us to revise something under plane geometry 1. We shall be using those techniques here. We've done it already, but I want us to recap our mind on the angles on parallel lines. You know parallel lines. Parallel lines are two or more straight lines that move in the same direction and do not meet. So, for example, these two lines are parallel. These two lines are parallel. You can also have something like this. All these lines are parallel to each other. You can also have something like this. These lines are also parallel to each other. We did that under plane geometry. Let's look at this diagram. Two lines that are parallel to each other and a transversal line. The angles formed when a transversal line is drawn to cross two parallel lines are very unique. First and foremost, we know this angle here and this angle here will be of the same value. Why? Because they are called vertically opposite angles. A and the H are also vertically opposite and they will also equal. Now D and J are alternating. We will normally say alternating angles always form the shape of a Z. Let's look at the Z. If I should trace like this, you can see a Z has been formed. So the angle here and the angle here are alternating. Their value are the same, A and J. Then A and C are also alternating. If I want to trace my Z, you will look at that. A. Good. So the angle here and the angle here are also alternating. So A and C are equal. D and B are corresponding angles and they are also equal. C and H are also corresponding angles and they are equal. So take note of these things. It's just a revision. Now let's come to something on what we are doing. If I have a compass here and I have another one here, no matter where I draw each of these compass, assume I have another one here, I have another one here. Anywhere you draw a compass, the north-south line in each case are always parallel. It implies if I should extend this line, extend this line, extend this one, extend this one, you can see that they are parallel lines. Similarly, the east-west lines in each case are also parallel. Let's do some extension. You'll appreciate what I mean. I'm extending this line. Then bring this line, this diagram a little bit so that it doesn't go to flash this one. So now let's extend this one, and then we extend the red one too as well. Extend the green one too as well. You can see what I'm talking about. So the cardinal points, no matter where you draw them, the north south line is always parallel to each other. The west eastern line is parallel at any point you draw them. So for example, if I have a cardinal point here, and I have another, a compass here, and I have another point here, and I can join these two with a straight line. Remember, I can take this as a parallel line to this one. Northeast line is parallel to this. In that case, this line becomes a transversal line. Let me do some little bit extension so that you see what I mean. I can extend this. I can extend this. Good. Extension here is not properly done. Okay. So this becomes a transversal line. So this should tell you that the angle here will alternate to the angle here. Look at my Z. The angle here will alternate to the angle here. So what the value of the angle here will always be the same as the one. Similarly, this angle will also alternate to this angle. When we view these ones as also parallels, let me also extend those lines so that we appreciate what I'm saying. I'm extending these lines too. They are also parallel, so you can see the Z. Let me even trace it so that you see. Use a yellow color to trace it so that you see. So this is my Z. So the angle here too will alternate to the angle here. This angle here will alternate to the angle here. Take note of that. It is very, very important. These two, this technique will be used throughout this discussion up to when the end of the lesson, where we'll be doing complex questions. So take note of that. Now let's pick a question and see how we're going to tackle reverse bearings and backward bearings. Based on, we'll be applying the technique, the knowledge we just revised based on parallel lines. Let's look at this question. If the bearing of A from B is 120 degrees, find the bearing of B from A. Pay critical attention to this keywords: A from B, B from A from B, and B from A. They are very keywords. When you have a situation such as this, you are given a bearing of A from B, and now you are now required to find the bearing of B from A. You should know that reverse bearing is in place. Bearings is just direction. So the bearing of B, A from B, the bearing of A from B actually means the direction of A from B. So I can even, if you like, remove the word bearing, and place direction in place. Replace it with direction so that you understand what I mean. Replace it with the word direction. Good. So it will be read as, if the direction of A from B is 120 degrees, find the direction or the bearing of B from A. What is the direction of the school field from the down class? What is the direction of Tukua Kwadade house from Achampong boys house? What is the direction of the headmaster's bungalow from the Hoko Beach? In fact, when I say what is the direction from the headmaster's bungalow, what's the direction of the headmaster's bungalow from the Hoko Beach, it implies you are giving the direction from the Hoko Beach towards the headmaster's bungalow. What's the direction of the headmaster's bungalow from the Hockey Beach? It means the direction should be given from the Hockey Beach. So from the Hockey Beach, you turn left, you turn this, you walk this, you turn right, blah blah blah. You get to the headmaster's house resident. So if you are being required to find the direction of A from B, it implies, if you are given a direction of A from B, it means that the angle that has been provided here is positioned at B. From B, it means at B you should turn 020 degrees and walk, it will take you to A. Then here we are supposed to find the direction of B from A. It means at A, if I want to come back to B, how many degrees should I turn? That will let me walk straight to B. Let's look at how this will be tackled. First and foremost, we'll draw our compass. Then we'll draw our 20 degrees. 10. That's our 20 degrees. Degrees. But remember, this is these points have been given. It is not like the previous question where you're only given the angles. This one, 2 relative points have been given. So after drawing the direction, you indicate your arrows, but you need to close the direction with another cardinal position. Good, like this, so that here becomes our B, because that is where the direction is being given from. The B is actually this place, but it can be placed, you can write the B anywhere closer to this place in order not to make the diagram haphazardly. If you place it here, the other things that will be written, etc., your diagram may look clumsy, so just place it anywhere closer to this place. It's accepted, but the exact position of the is here, the B. Then here will be our A as usual. You don't need to place it at the point here. That is the exact position of the A, but you place it anywhere closer to this line. That the point is accepted. As we're doing compass bearing, you must also always indicate your angle. So this is 020 degrees. This is 020 degrees. Let me put it there. And then enclose the place of an arc. Sorry for that. Enclose the place of an arc. So this is the diagram representing a bearing of A from B. That is 20 degrees. It means that B, I have to turn 20 degrees in the clockwise direction. Then I walk to take me to A. Now the question is requiring us to find the bearing of B from A. This time around the angle should be at A. At A, how many degrees should I turn? How many degrees should I turn before walking down to B? So we are going to look for the value of this angle right from the north pole of A through the south pole up to this point. Remember that this is a 30th bearing. That is why at the north pole, at A, we are taking the angle from the north pole to the clockwise direction up to the line. We also realize that from our discussion that when I extend this line and I extend this line, the power line, it makes this a transversal line. In that case, the angle here will alternate with the angle here. So if here is 20 degrees, it means this place will also be 20 degrees. So I can place it there. A small portion there will be 20 degrees. The small space here is 20 degrees. So to find the complete turn from the north pole up to this line, we only add the 20 to the 180. I don't need to tell you where I'm getting the 180 from. You should be conversant with these standard angles, 90, 180, 270. So the bearing of B from A in this scenario, the bearing of B from A will be the 20 degrees plus 180 degrees. Let me remind degree sign. Sorry, plus 180 degrees. And this will give me 200 degrees. Sorry, to give me 200 degrees. So that is that. That it is. I'm going to do about 2 more examples. Then I'll give an example to an exercise to try. Let's look at another question. We are taking another question now. If the bearing of Q from P is 120 degrees, find the bearing of P from Q. Another backward bearing in place. As I said earlier on, when you see the letters interchanging, P from Q from P, P from Q, this is an indication that a backward bearing is in place. So what we do is to sketch our bearing. Q from P, the angle will be at P, 120 degrees. This is the 3-digit bearing, so We will take the measurement from the North Pole in the clockwise direction. Up to here is 90, so we are adding 30 degrees to the 90. That is it. I said you must close it with another compass. We indicate the direction of an arrow. Now we know that the first place where the angle is supposed to be is where they say from. So 120 from P is 120, so the angle will be at P, so here should be called P. Then the other side will be called Q. We have to enclose the 10 with an arc 120 degrees. Now the question is asking us to calculate the value of the angle at Q. That is the bearing of P from Q. The bearing of P from Q. So now the emphasis is on Q, the angle at Q. But before then, let's analyze. See how we are going to tackle this. Now at Q, the bearing of P from Q, if you're looking for the angle at Q, this is a 3-digit bearing. It will be measured from the North Pole of Q through the clockwise direction up to this line. So we are looking for the value of the angle from this point up to this line. There are so many ways we can get that. One, if we know the value of the angle here, we can subtract from 360, and the remaining angle will represent the 10 of from the North Pole through the clockwise direction up to this line. In fact, you can see that turning from the North Pole up to this line, it is only left to this area for us to get a complete turn. The angle here if I should call it theta, would be the same angle here. They are alternating. Look at the Z. So once I know the angle here, I will know the value of the angle here. So theta the value of theta will be equal to 180 minus 120. 180 degrees minus 120 degrees. You can see that the turn from the North Pole over here up to this line is 180 degrees, but I turn from this portion up to this portion is 120. So to get the remaining portion here, we just subtract the 120 from 180, and we will see that it is equal to 60 degrees. So the turn from this portion up to this portion can be calculated by subtracting this theta from 360. Now we know the value of theta is 60, so we can take that out of 360, and the remaining will be the bearing of P from Q. So the bearing of P from Q will be equal to 360 degrees. Take away the value of theta, and that is 60 degrees, and our answer will be 300 degrees. Let's look at this. Assuming, let's look at this. We're given 120 degrees. Let's add 180 degrees to it and see what happens. If we add 120 to 180, the value is 300 degrees. We'll come back to this, but at this point I just want you to just look at something. If we could have added 180 degrees straight away to get a 300. I will come out I will explain why this statement later on, but if we want to find out how this 300 can be achieved based on the principles going by the diagrams, this is how it could be done. Let's look at another question. The bearing of M. Let me increase the font size so that you can really see what is on the screen. The bearing of M from N is 200 degrees. What is the bearing of N from M? Another form of reverse bearing. Let's look at this question. The bearing of M from N is 200. What is the bearing of N from M? Let's sketch the bearing of M from N, 200 degrees, clockwise direction. This 180, so you adding 20. Beg pardon, you need to start this drawing from the top. Adding 20 to the 180. Enclose our drawing with another cardinal point. Indicate the direction with an arrow. Our angle is 120 degrees. Sorry, 200 degrees. we indicate the value of the angle. Good. We name the relative positions, that is M and N. We know that the angle is supposed to be at N, so this position will be called N, whereas the position here will be called M. The bearing of M from N, the angle will always be at where the from is, from N. Now we are going to calculate the bearing of N from N. What the question requires is the angle here. We need to find the value of the angle at this position. Good. Because at M, we'll turn to the clockwise direction from the North Pole up to this line, and then we'll move up. So if we are looking for the angle over there, let's name that angle theta. With what we learned earlier, theta will alternate to the small angle here. So here will also be theta. Once we know the value of this small angle theta, then it is the same thing as the value of this angle. But looking at this place, the total term from this point up to the line is 200, but from here up to the south is 180. Hence our theta will be equal to our theta will be equal to 180 degrees, 200 degrees our theta will be equal to 200 degrees minus 180 degrees, and that will give us 20 degrees. Henceforth, we can say that the bearing of M from N, we can say the bearing of M from N, beg your pardon, from N is 0 to 0 degrees. Remember, we are doing 3-digit bearing. 0 to 0 degrees. If the question is given in 3 digits, you are asked to find the reverse. Do not always forget to also leave your answer in 3 digits. That is it. Let's look at another question. If the bearing of A from S is 300, find the bearing of S from A. Another display of backward bearing or reverse bearing. So the first thing which you need to do is to draw the bearing of A from S, 300 degrees. Clockwise direction, 300 degrees will be here. And close the place with another arc, another compass. Cardinal point. locate my 300 degrees turn from the North Pole. This position will be called S. The angle is located at S. And this position will be our A. This is the flow, the direction. And the value of the angle 300 degrees must also be inserted. But we are looking for the bearing of S from A, so we will look out for the angle here. We are looking for the angle from the North Pole of A up to the line. We know from A, North Pole of A up to this point is 90. So we only need to calculate the value here. And the value of this angle is the same thing as the angle here. They are alternating. So if here is theta, this position will also be theta, alternating. Look at the Z. So if we know the theta, then we can add it to the 90 to get a complete turn. The value of our theta will equal to 300 degrees minus 270 degrees, and that will give us 30 degrees. Remember, the turn from the North Pole, the clockwise direction up to this point is 300 degrees, but up to the west is 270. So the surplus here is what we are looking at for, and that is 30 degrees. When we subtract it to find the difference between 270 and 300. This implies the bearing of S from A will be 90 degrees plus 30 degrees. And that will give us 120 degrees. Let's look at 300 degrees. Minus 180 degrees. It also gives us 120 degrees. So this is how we find the values of reverse bearing in 3 digits. We'll look at compass bearing as well. But there's a general convention. We don't need to always, if it's an objective question, to always be drawing the diagram. But the diagrams make you understand what actually goes on. That's why I took the pain to draw the diagrams and then show you how the reverse bearings are obtained. It gives you much understanding of bearings. But there's a general convention we shall discuss in the next screen. Let's look at the questions we have discussed so far. The first question, an angle of 120 degrees was given, and when we found the backward bearing, it was 300. The second, 120 was given. Sorry, the first one we got 200. The second one, when the backwards bearing 120 was given, it backwards was 300. The third, 200 was given, backward was 20. 300 has been given, backwards is 120. Now let's separate this. Anytime an angle is given and the angle is less than 180 degrees, if you want to find a backward bearing, all that you need to do is just to add 180 to it to get a backward bearing. With this category, when the angle is given and it's more than 180 degrees, you subtract 180 from it, you'll get a backward bearing. For instance, let's look at a question, another question. The bearing of A from Y is 45 degrees. What is the bearing of Y from A? Automatically, by the convention I've just said, if A from Y is 45 degrees, 45 is less than 180 degrees, so only add 180 to get the answer. So adding 180 to 45 degrees, the answer will be equal to 225 degrees. 225 degrees. Let's use sketch to see whether it will be true that way. We first draw our sketch the first diagram. This one comes down small. 45 degrees, bearing of 45 degrees, you know, to lie in between east and north. North and east. Okay, we enclose the position. 3, the position over there is always very important. Indicate our direction. Label the relative position X, Y, and Y and A, and where the angle is we call Y, whereas A will be at the other side. My angle is 45 degrees. 45 degrees. I enclose the place with an arc, a neat arc, of course. Now, what we are looking for is Y from A. Now, the angle will be at A. A 10 from this after this point. We can see clearly from the diagram that to find the value of this angle, we need to add the value of the angle here to 180, and the value of the angle here is 45, because the 45 here alternates to this angle. So adding 45 to 180 will get our 225. So it means the convention that I spoke about is working. Let's look at another example. Let's take another question in this category. The bearing of T from S is 290 degrees. What is the bearing of S from T? Backward bearing. The angle provided is more than 180 degrees. So we need to subtract 180 from it to get a backward bearing. So in that instance, 290 minus 180, the answer will be 110 degrees. Let's use the diagram approach to see whether this is working. It's really working, whether we are still on the right path. So with the diagram approach, our first sketch, mine 290 degrees. 290 degrees. $290 is a little bit above 270. That's 20. Just adding 20 degrees to 270. Then we close area with cardinal point. This is the direction. Now we'll label the relative positions. This position will be called T, whereas the position here will be called S. The turn of the angle is on the north pole of S, clockwise direction, up to this position, and the value is 290 degrees. Now what we are looking for is a turn from the north pole at T, this line, and we know it will be 90 degrees plus theta here, and this theta is exactly the same thing as the small one here, from here up to the line here. And as we said earlier on, we added only 20 degrees to the 270 to get 290. So the theta here will be 20 degrees, which is equal to 20 degrees here. So this value is 20 degrees. We added to the 90 degrees to get a complete turn from this north pole up to the line. And 20 degrees plus 90 degrees will give us a 110 as we had here. So whether you go by the diagram approach or whether you use this convention, you are always going to get the same answer. You are always going to get the same answer. We are still on reverse bearing. The next aspect is to find reverse bearing in terms of compass bearings. Always remember, when a question is given in compass bearing and asked to find any other bearing, you have to leave your answer in compass bearing the way it is. If it's given in 3-figure bearing, you leave your answer as such. So let's now look at how we can find reverse bearings when they are given in terms of compass bearing.